Welcome to Factoring the Difference of Two Squares. This is section 11.5, and we are going to take a quick look. Remember yesterday we multiplied binomials together, and they were kind of special binomials. They were such that when you did your double distributive property, like we're doing here, x squared minus 3x, and then we get 3x minus 9. Because the way the two original terms were set up, when we combine like terms, we had the middle terms zero out. Now those would be the inner and outer terms if you FOIL. If you're using box method, those terms would be on the diagonal. We are going to talk about how to factor things like x squared minus 9, which are called difference of two squares. Basically, we're going to be doing the exact opposite of what we did in the second half of yesterday's assignment. Well, if you take a look here in the original problem, x is the square root of x squared, and 3 is the square root of 9. So there's a square root kind of vibe going on here that we can use to help us factor these things. If you want to factor a squared minus b squared, we do that by taking the square root of a squared, which is a, the square root of b squared, which is b, and then putting in a plus and a minus. This will check out by foiling or by double distributive property to show that a plus b times a minus b is a squared minus b squared. Alright, you can't always use difference of two squares. There has to be a couple of things going on. Both terms must be perfect squares. The exponents have to be even, and there has to be a minus sign between the two terms. So an example of something that would fail, I couldn't do 7x squared minus 9 because 7 is not a perfect square. I could not do x cubed minus 1 because I have an odd exponent and I must have even exponents for it to work. Another example of something that is not difference of two squares would have that plus sign in there. So say we had x to the fourth plus 16. Even though x to the fourth is a perfect square and 16 is also a perfect square, it has to have that minus sign. Okay. And then there's a fourth category here which isn't quite as important as the others because it doesn't come up that often. Even number of places with decimals. So what we're saying here is 0.0064 is a perfect square. So the square root of that's 0.8. But 0.064, because it's not an even number of decimal places, is not a perfect square. So not a perfect square, not difference of two squares, not difference of two squares, fail, fail, fail. So as you can see, our first exercise here, we want to determine if you have difference of squares. So perfect square, this is good. 4r squared minus b squared, those are all perfect squares with a minus sign in between. Plus sign, uh-oh, no good. 7's not a perfect square, uh-oh. 0.9, that's only one decimal place. Need to have an even number of decimal places. Ah, here we go, 0.09, that's much better. Both of them are perfect squares. There's a minus sign in between. 9/25, if you can take the square root of 9 and the square root of 25, it's a perfect square. It is, and this one works. Let's see, a cubed, odd exponents, no good. Negative 9 plus m squared, consider that can be rewritten as m squared minus 9. And when you see it like that, you can see it does work. Okay. So let's do this here. We got r squared minus 9. As you can see, our first example's worked out for you. The square root of r squared is r. The square root of 9 is 3. So we put the square root of r squared in the first spots. We put the square root of 9 in the second spots, and then we throw a plus minus in there. Let's see. Example 2. The square root of 25 is 5. The square root of x squared is x. The square root of 1 is 1. The square root of 49 is 7. And the square root of y squared is y. So all square roots here. 5x plus 1/7 y, 5x minus 1/7 y. Alright, example 3 is important because it talks about how to take the square root of a couple of different things. Alright, when I take the square root of 0.04, I'm going to cut the number of decimal places in half. There was 2 decimal places. When I take the square root, there's only going to be 1 decimal place. So 0.2, 0.2, throw in a plus minus. When you take the square root of an even exponent, you divide that in half. So half of 6 is 3. And half of 4 is 2. So final answer, 0.2 plus c cubed d squared times 0.2 minus c cubed d squared. Alright, let's get into our examples here. The square root of x squared is x. The square root of 100 is 10. And then we go plus minus. Done. The square root of y squared is y. The square root of 144 is 12. It was 2 decimal places, so now we have to have 1 decimal place. Take the number of decimal places, divide it in half, do plus minus. 0.16 has 2 decimal places. When we take the square root of that and get 4, we're going to want 1 decimal place. Half of 2 is 1. Okay, square root of m squared is m. Square root of 9 is 3, plus minus. Take the exponent and divide it by 2 to take the square root of x to the 4th. That's x squared. Square root of 81 is 9, plus minus. 0.0064, well that has 4 decimal places. So when I take the square root of 64 and get 8, I'm going to need 2 decimal places. That can only happen with a leading 0, so I'm going to put a 0 there. Okay, square root of y to the 4th, divide 4 by 2, y squared. Look at that. Next page. We're almost done here. 58, that's not a perfect square, but don't forget what we did the other night. We can take out a GCF if necessary to accomplish this. So if I bring up my calculator here, 58 divided by 4, I think of 4 because 4 goes into 16, gives me 14.5. How about 58 divided by 2? Gives me 29. 58 divided by 8 gives me 7.25. So, do we even have a perfect square? Well, let's try to take out 2 and see what we get. So if we take a 2 out, 58 divided by 2 is 29. And 16 divided by 2 is 8. And that is as good as we are going to be able to go. Don't forget GCFs do happen. In this case, that's the best we can do. In this particular problem, this is like a little bit of a spicy one. The square root of x minus y squared is x minus y. The square root of 4 is 2, so I'll go plus 2 and minus 2, and it's done. It's kind of a weird looking answer. Well, we literally have the difference of 2 squares here. We have a big square and we have a little square. The big square has sides length x and the little square has sides length y. Well, remember, area of a square is side squared. So the area of the big square is going to be x squared. The area of the little square, which is not shaded, is going to be y squared. So the area of the shaded region is x squared minus y squared. You will see a couple of problems like that on your assignment. I look forward to seeing you tomorrow. Please remember to bring your textbook and we will give some of these problems a try. Thank you.